Yo, what's up guys, and today I'm going to be talking more about how I'm going to code Conway's Game of Life on my Minecraft computer. First things first, I want to change a decision I made last video. I explained how by using only 16 extra bytes of RAM, I can store temporary rows and then replace already checked rows while still checking the rest of the grid. It's a little odd, but that was my solution to using less RAM. But after coding all this, I realized that it adds a lot of extra instructions to the program, which would cause a lot of delay. So I'm going back to the simplest option, which, despite using more RAM, is going to be much faster. The simplest option being just having another 64 bytes to store the new grid, and then once I've checked everything, move everything back over. Another thing I want to explain is that instead of storing the alive and dead cells as ones and zeros in the memory, I want to store them as 0 and 255. Well, why would I do this? To determine if a cell is alive or dead, I need to check the number of alive cells around it, and this would require an if statement to say whether a particular cell, is alive or dead. What I'm going to be using is something called the zero flag, which simply just says if the output of a math problem is equal to 0. My ALU, which does the math for my computer, is set to 1 for most of the program. A lot of the functions require it to be +1, which just means I give it a number and it will add 1 to that number. Now let's say I was storing the cell data as 0, dead, or 1, alive. In order to activate that 0 register, I would need to first set the ALU to +0, and then put my number through to determine if it's a 0 or a 1, and then I'd have to set it back to +1. This would take 3 instructions, but I felt there has to be a faster way. One thing I noticed is that throughout almost the entire program, the ALU is set to +1. So why not work with that? Why not make it 1 less than it should be? And then I don't need to modify the ALU at all. So 1 less than 1 is 0, and then 1 less than 0 is what? -1? Well, no, not really. Let's look at where I got this 255 number from. So this is 255 as an 8-bit binary number. It is just 8 ones. Now, if we were to add 1 to this, well, we know this would be 256. But in binary, you must represent it with 9 bits. Well, if my computer is only 8 bits, it would only look at the bottom 8, and it will just see a 0. So to use less instructions and to work with the computer, I can represent dead as 255 and alive as 0. The final thing I want to cover is the interface. How am I going to select and or unselect certain cells? Well, I can't interact with the screen. I can't physically touch the cells to turn it on or off. What I can do is I can enter the number of the cell, 0 through 63, and this number works for both the screen and for the RAM. Cell number 33 on the screen correlates to the address 33 in memory. So you enter your number, and then what I want the program to do is if the cell is off, turn it on, and if it's already on, turn it off. So today we talked about how the simplest method for running the simulation, even though it takes up more RAM, is the best. We talked about how I can store the dead cells as 255 and the alive cells as 0. And for the user interface, I can toggle the state of a cell by simply entering its correlating number. By next video, I should be fully ready to demo the Game of Life. So stay tuned for that, and peace.